Thank you for coming. So the idea today is to share a little bit what we are doing in the lab, and not only that, but also is like what kind of direction are we taking in general for the product, how we plan to keep improving it using new tools, and thanks to a lot of third-party solutions like Azure, it makes everything easier when it comes to deployment. Okay, so what's the Improv Labs? They are basically ad hoc teams to create innovative solutions that require some specialized knowledge. Then I will tell you who are in the team today. And there's a couple of core principles. One of them is short idea to monetization period, which means we run very small projects, very short, from inception to proof of concept. We leverage on third-party solutions, cloud solutions, to move quickly from prototype to actual production, and also this fail-fast mindset. So if it doesn't work, we tried, we figure out if it doesn't work, okay, we won't waste money on these, we'll just move forward and try to think about something smarter or even better. And then strategic alignment with the core business. So we won't be doing any random cool stuff. I mean, it would be nice to make a chatbot, right? But it wouldn't fit our business profile. So it has to improve what we do currently, potentially targeting, allowing us to target new customers, and then introduce innovations that actually nowadays are nice to have, but then probably and very likely it will become a requirement in the industry. So the areas of innovation are machine learning, natural language processing, data mining / discovery techniques, data visualization, and high frequency data. Especially high frequency data is something we are probably going to continue working or start working later this year with MiFID II, where this will become a big topic. In this term, so we are focusing on machine learning and natural language processing. And for that, we created a very good team. And to succeed, we had to hire the best. And I think we managed to get a very good team. We have Lars here. He's in a couple of months, 2, 3 months, 4 months. He's finishing his PhD in computational linguistics at NTNU. Then we have Ivan also, specializing in AI in NTNU as well. So we had a lot of recruitment from there. And then Anastasia, financial economics from BI. And also, very good mentions here. Ture has been helping, JT, and everyone had. Lauritz has been also helping. So a lot of the core team has been helping, and we really appreciate that. And it's great that you guys get involved. So if you have any idea, random idea, it doesn't matter if you are from the engineering side or sales side. If you have ideas, just bring them. No idea is stupid. It actually can end up in very cool products. So why are we doing actually this? And the reason lies actually in the DNA. Not long ago we had this meeting and we talked about the Improv DNA. And one of them was automation. So the automation here, it happens in 2 levels, right? Our internal processes as well as products. The product is moving towards, let's say, smarter solutions. So when it comes to automation, now we are building a couple of tools. One of them that we're actually working is automated data classification. So an algorithm just bring me the data and then they will tell you exactly what is that. So then a lot of this cumbersome process of manually tagging data will be obsolete, hopefully. And also a project that we would like to run later on would be automated leads generation. So using web scraping, using some AI, we will be able to facilitate the sales team with cool leads, solid leads, and with some sort of significance of, okay, this guy is actually going to buy. Nice. And then new products, right? So it's important that we have a lot of raw data, but we don't extract as much value as we could. We could be generating data derivatives, but we don't too much. We are starting to do that very slowly, But if we start to automate a lot of these things and get insights, then we'll be able to generate these derivatives. And then continue expanding and cut through the noise. So more data mining, text summarization, entity recognition, signal generation, recommender systems, etc. So also from our perspective, so everyone is talking about AI, and we should think about, let's say, beyond just the buzzword, because these are techniques that are coming and no one can stop it. And a lot of people might think, okay, these are jobs that are going to be lost in the banking sector. We don't think like that. We actually think that these tools are going to empower financial professionals, because you will be able to do things that you were not able to do before. They ask you, okay, I want to do an analysis about this industry, this sector, and suddenly you have millions of documents. As a human being, you cannot do that. But as a computer, as a machine, it's like, okay, sure, bring it on. So those kind of tools, these new techniques will empower financial analysts or professionals in general to a brand new level. And that's when we talk about augmentation. So we believe on this concept of augmented analytics, and that's definitely the way to the future. And that's the reason what we are studying today should be something that should involve all of us. So now a little bit more about the industry. So these are the revenue, how it's going to grow from today, from last year to 2025. It's expected to reach 60 billion. It's important to understand this number. This is pure AI software. It doesn't mean that the fact, for example, if Imprint starts to add AI, it will sell more. That is not included in that figure. And as you can see, finance today, or last year actually, has a fairly big share of the total AI revenue. Where is it? Here, 3%, and investment 3%, so in total 6%. This trend will continue growing, as we will see later. But the main competitors here in this case are startups, and many of them actually, are financed by either banks or our competitors, big competitors such as Bloomberg and Reuters. Bloomberg has a VC arm that is investing heavily in these things. And the reason they don't want to do that internally as a company is because they fear that they are grown-up companies and they won't be able to catch up and innovate as a startup would. But what about IBM? That's the most mature tech company, and now you have Watson, which is great. So it's important to see how it's going to be for us, how easy we're going to adapt. I think we're a very small and dynamic team, so it's going to be cool to see how we embrace this. By 2025, finance and investment is about 10%, and it will generate just AI, not what the addition of these tools might generate to sales. So it's just AI purely. It's about 700 million, which is, I think it's a very low figure on these projections. There's a reality as well. There's going to be less people at the banks and investment firms. But because a lot of these, what they are called now Excel monkey tasks, are going to be automated to better technology. So the toolbox that we have different layers: foundational, cognitive, system layer, sensory layer. So there's a couple of things, a couple of tools that this is not the full picture, but these are kind of the main tools we are using, ranging from statistics and econometrics that are inherent to finance to machine translation, etc. So I will just give you a brief introduction to the projects, and then I will give it to Lars, who will explain a bit what are the techniques, what is innovation, and what we are doing. So of the things we are building now, okay. Document classification. What I call it, yes.
You've hided them.
Okay. So the idea is that you take any data input and we classify it. It doesn't matter if it's an analyst comment, if it is macroeconomic data coming from a central bank, the algorithm knows exactly what it is and it will be automatically classified. That will help us to make everything more searchable and relevant, so you don't get a lot of noise. We'll manage to keep it clean, since we disregard non-relevant articles. These will run as web service using Azure. And the good thing about this project is that we are very advanced on this. Next week we will have the first prototype, and then the production version will come shortly after. Multi-document summarization. So what we were talking before is, okay, I want to know what happened with Statoil, let's say, during the last year. I want to know the most important events, the most relevant things. For an analyst, it will take a couple of days probably to go over and create that summary, some sort of executive summary. For our algorithm, it will take under a second or a second max. So this is a great tool to be able to just extract, because one thing is data, the other one is information. Information is a tiny piece of the data. So the idea is that here you will be able to extract information. You will just not get the data. So for example, you ask, okay, give me fingerprints last month or last year, then you get a summary, then you get some key events, performance, etc. This will be something that will improve our core product as well. Trending topics, then just at a glance, you can have a view of what's going on in the global economy or this sector or this country. And you also can get historical trends such as Google Trends now. So you can see, okay, how often this happened. Then topic models. So more data mining based on text. And also we are going to start to add quantitative layers on top of this text information. And then we have some fixed income projects, which is part of what we were talking before about creating data derivatives. So we add value on top of our existing offer. So we will get aggregate risk premiums per country, per sector, currency, etc. And also we will be able to create some sort of prediction models regarding the transition probabilities from one state, let's say AAA to B, or from C to A. So now, yes, soon to be Dr. Lars.
Yeah, sure. How do I click sort of arrows?
Yeah, and also you have this.
Oh.
Yeah, probably use the mouse. Yeah.
All right. Well, thank you, Alan. I just thought I'd say sum up natural language processing in one sentence. That's very short, of course, but just to try to give you an idea of what we're doing. In terms of the history of processing natural language, as we say, as opposed to controlled languages such as programming languages or Esperanto or those things, processing natural language, whether text or speech, is inherently very challenging because it is a moving target. Now, when computers were slower, to put it in a simplified way, elaborate grammars, rule sets were written. Nowadays, last 20-25 years, we've kind of moved into data science, big data, all those words, just processing huge amounts of data instead. So instead of the old expert systems that you might know from the 1980s, instead now you try to create features of everything and just process that in a huge computer and infer the relations. And that has been very successful because of, the size of computers. I thought I'd talk a little bit about what a bag of words is, what a vector space model is, very briefly. Imagine a bag of words. You put words in a bag. It's a multi-set, which means that words can appear more times. So if I say yes, 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 no, no, you have a vocabulary of 2 words appearing 3 and 2 times respectively. Now you can visualize that with a word cloud that's at the bottom there, where you see how many. This is a small vocabulary over some news articles. You just run a word cloud on, and you see that those mentioned more times are bigger. Now, is this a pointer? Oh yeah. Now you could also represent that by a vector, right? Those numbers are just picked out randomly here on occurrence. So this represents a vocabulary, and this will be one word, another word, and so on. And this is just how many times they occur in a certain document or document collection. Now you can stack those. You stack vectors, you get matrices. And you can do math on these matrices and discover nice things. I should have put that bullet under this one. But anyway, you can derive semantics. Semantics is a linguistic concept. It means what does it really mean. It's a very hard concept because it's hard for us humans even to know what stuff means, what words mean, sentences mean, because we have this fantastic disambiguation facility inside ourselves that just means that, as you know, words can mean different things. In English, for example, all nouns can be verbs almost. You can table a motion, or you can motion a table, right? But we can infer what's being meant. But imagine doing that in a rule-based way in a computer is very difficult. And that's one of the huge challenges. But it has been shown that by processing these huge vector space models, we are able to do some fun things. Now, this is a very, very frequently cited example. It was a guy called Tomasz Mikolov who did some really good work some 5-6 years ago, creating something called word embeddings, which are representations of words that take the context they appear in into account. And then he simply did some simple arithmetic on those vectors, and he took the vector for king, subtracted the vector for man, added the vector for woman, and got the vector for queen out, or the simpler one. Similar, yeah. Not exactly, but one similar to it. And you can also, so this is a way of showing that you can indeed find these semantic relations. There are other examples of it, but this is perhaps the most cited one, just to illustrate the point. So that's how you can do computational semantics, or semantics computationally with these vector space models, and that's how we can also infer relations between documents and topics and words and so on. All right, so
I'm going to do the classifier slide. So basically, what's the classifications? As Alan sort of explained a few months ago, basically we have sort of documents, and we want to find out what they're related to, what their tags is, what the category is, what companies are mentioned, etc. So basically what you have is you have a document, and you want to build a model that you can take the document in as a sort of future vector based upon bag of words representation, etc., or some sort of term frequency, and then we want to output these labels or etc. So the question is, how do we do this? How do we train this model? We use something in user called supervised learning. Basically, we have a bunch of training data with these labels, and we input them into the algorithm, and then we tell the algorithm what is wrong and what is correct, and then it sort of updates its internal parameters. So when we try it on the real data, it will classify the new instances correctly. So there are different methods of doing this. Some of the three most common are support vector machine, random forest, and neural networks. A support vector machine is basically you have your data in this d-dimensional space, where d is the number of features that you decide to represent each document with. And then you want to find this hyperplane, so
features
this lines.
are tags.
Features are tags, yeah, basically, yeah. That's your classifications. And you want to sort of find this plane or this line, so you can correctly split the data. And if it's not linear or separable, which is often the case, you can use something called kernel, which basically is a hyperbolic function, etc. Yeah. Random forest, I don't know if people are familiar with decision trees and flow charts, etc. Basically, you go from tag to tag, and you ask, features, attributes, word to words, and you ask, is this word present or is it not present? And then you move down the tree, and then at the at the leaf nodes at the bottom of the tree, you will have a bunch of labels which tell you that if you went there, then it's this tag. If you went there, it's that tag. The problem with these decision trees is that they're highly sort of customized towards how you split each node. So what you want is have a random forest. It basically means you build a bunch of these trees and then you assemble them. So each tree does well on certain documents, and other trees will do well on other documents or features, etc. And then we have the neural networks, the sort of hot topic within AI, which is basically it's inspired by the human brain. So you build a network with nodes and weights, and then what you do is you propagate your documents through this network, and for each node you have basically a summation and an activation node, and then that decides how much you want forward until the next layer, and so on. And then at the end you have your classification, whether it's yes or no for that certain tag. Neural networks has gained a lot of attention lately due to very good results on image recognition. You can recognize cats and so on in pictures and videos, and yeah, you can now train very, very large neural networks, but you have these fast graphical processing units, basically your screen cards in your computer. Yeah. So that's basically what the state of the art is of classification.
Face app. I don't know if you know that app that you take a picture and then you can become old and stuff like that. It's all neural networks. So it has a lot of applications. Really cool stuff. Very cool, exciting tech. Yes, next slide. Yeah, sure.
A few words on multi-document summarization. This is it's not by any means a trivial task, but it will involve a two-step operation. First, we need to retrieve the relevant documents through the query. That's an information retrieval lingo, that. But the way we think of it is you start with some query, which means that we start with a company, a sector, and a time frame. You retrieve n. N means just a number of. You retrieve n documents that are relevant to the query. You rank them somehow, and you do a cutoff, and then you summarize those documents. Now, with regard to document summarization, there are two main avenues of research or ways of doing it. And they're split into abstractive summaries, which means that in research that you'll always have to write these abstracts, but it's just a synopsis of what's in there. And that's challenging because you need to mold sentences and you merge them and you need to have the fill words correctly and so on. That's difficult to do, and you risk ending up with incorrect English or incorrect language. I guess in principle you can use any language. The other way of doing it, which is easier in terms of grammar, is to extract sentences. So those are called extractive summaries, which means that you create a representation, a vector representation of all sentences in your document or in your collection of documents that you want to summarize, and you rank those sentences. And then you output the best sentences according to your ranker in a sensible order. So that is what we are going to attempt here, and then, of course, there is a lot more to this. I mean, how many do we output? How many do we output with regard to how many documents we retrieve, and so on. But this could potentially be very useful also in combination with things Alan has been speaking of, such as the named entity recognition, which is a technique to figure out what passages of text in a running document are actually entities and not just strings about something, right?
Meaning, like, okay, I get a lot of documents and it tell me, okay, who was mentioned in all of these documents, and then you get like, okay, Lars, Ture, Tron, etc. And then you get that right away. And then you can search, for example, okay, I want information about the CEO, and then you get all the articles where the CEO was mentioned.
So ideally, it should know that Big Blue is IBM, right? Journalist talked about Big Blue. He's actually talking about IBM, and then you can, so your algorithm can know that. I don't know if we'll be able to catch that one, or the Louis will lip is Muhammad Ali, right? And that's kind of the idea to try to capture that those things are about the same thing, and that could possibly be presented alongside such a summary and be informative. But those are the two main directions of it, where we will likely go for the extractive here, because that's feasible to do. But of course, as you could well imagine, there are challenges also with that. You have the problem of non sequitur passages, which simply mean that you put arguments after one another that do not make sense. It doesn't logically sense. You can put you run into risks such as that, but you don't run into the risk of writing very clumsy English, writing like a child or writing like someone who doesn't know it at all, which could possibly not be good for how companies want to appear and so on. So that's why that's probably a better way of doing it. Okay. Some trending topics. This is more like a simple idea, but since we are working with such great structure here, we look at the documentation for the structure of the newswire corpus is like this. It's a very, very elaborate system of tagging them, of having experts actually labeling them with what they're about and so on. So there's an obvious, or there is a potential benefit from just aggregating data like that and presenting it in a way where but this would then be essentially based on counting this, a bit like very simple things like trending hashtags on Twitter almost, right? So you have all these tags, and there could be some information in the frequency, how often they appear, and the relative frequency of these tags. So if you put in a company, a ticker, something ISIN, and you can see that lately there has been a lot on golf or food or whatever, that could possibly provide information to someone. And we could just put in some humble pie here as well, right? Because obviously we are not experts in the domain like you are, right? So it's hard to know what would actually be useful to someone who makes a living by reading these texts and producing new text, for example. But something like that could potentially, at least it's imaginable to me that it would be useful for someone who does analysis.
Maybe we can jump to Q&A. So if you have any questions, both the people sitting here and online, just shoot. If you have any idea, any comment. Yes?
Do you have any experience or examples of what differentiates a good from a bad sentence in such a training model? Maybe it's a too specific question.
Oh, you mean
it is a very good question. So the thing is, maybe Lars is the right guy to answer this question, but a sentence is transformed into a vector. Then you can assess the similarity and the weight of each one. And then just extract the vector that has the highest score among similar vectors. Maybe.
Yeah. It depends on if you were thinking about summarization. Was that to extract?
Through extraction,
For
right?
example, if you want to extract the most relevant sentences, then you would first do some kind of processing of the matrices to find the most important terms. And then you would say, to this query, these terms are most important. And then you can see the frequency of those terms inside the sentences.
Could that be related to the cloud? The word bag, for example?
Yeah, it would be. It would be. Of course, the word bag was kind of a simplification because let's say, you put fancy things into the bags, right? You do some processing to extract more sentences, but I mean, such systems have also been used based on rules and expert knowledge, right? For example, if you are a financial expert, you might know that these expressions are very, very relevant, and then you can give that a high feature value. And you can use hybrid systems that you can create features, because feature is any numerical representation of the entity, right? It could be anything, right? So you could, for example, you can have experts say that these 50 terms are the most important for foreign exchange markets, for example, and then you can count the frequencies of those and just include that in the vector. So that answers, yeah.
Yes.
Yeah.
Any question regarding strategy? What we are doing? Why? How can these improve your workflow every day? There's something you would like to automate from your daily tasks. Those are
Are users setting up what they would like to these things to learn, or are you guys providing this is what's interesting for you?
No. The whole point of creating tags or features, as it's called in this area, is that you have filters, right? So you can select exactly what you are looking for, even with a higher degree of specificity than before, because you can say, okay, I want news about this sector that mentions this guy. Now you cannot check for people. Now you can. Well, soon. Or location. Alberta, Canada.
So this, of course, is highly relevant for news sources as we view them today, because the way you use the terminal today is very much a fire hose strategy, in where you try to desperately filter out stuff that's interesting.
Yeah.
I assume that that is a target for this.
Correct. Cut through the noise.
Yes, exactly. I assume that you have to follow up with a more advanced user-facing.
Correct. So we
thinking about that as well.
Yes, we are thinking about different front ends, simplified, hopefully running fully web, some sort of like widget integration as in financials, so then we can easily use it across all front ends. Yeah, I think it's very exciting, and this is not just about creating products, but also making us more efficient technically. We can automate a lot of things. So
I guess the first phase is to do with news and stuff, but will there be a phase later where you compare the qualitative with the quantitative data?
that's actually the whole aim, is where we managed to merge the two. And actually the main product, because now we have competitors such as Autostech that has Lingo. Bloomberg also provide these sort of very static template-like reports. Our system so far seems to be better because we extract useful information from existing articles, as well as we can provide quantitative insight with the templates like Otas or Bloomberg are doing. So then you get, okay, this month was this, compared with the sector, the performance was blah, 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 etc. So yeah, and that goes tied with what Andreas mentioned, creating pleasing, intuitive, easy to understand front ends.
It also means that we would get something as simple as previously untagged sources that other people show us, they don't have as untagged, that we actually will have as tagged, so that we can filter on content.
Yes, correct. That's
really, really cool.
It is extremely cool and powerful.
Yes.
Because suddenly we have the opportunity to source whatever. Things coming from central banks, analysts, blogs, whatever, and we can actually classify it.
I mean, stuff that we today see as basically filler. Public news sources, newspapers, all that, we could turn that into a premium news source. It's really cool. Exactly.
It adds a lot of value. So it's very good that you can see it, because sometimes, applying these things are hard sell.
This is one of the most normal criticisms about our news system, is that it's not tagged. It doesn't have good ways of filtering. A lot of the sources are basically useless. Mm-hmm. But we still have them there, so there's so many of them.
And we own news agencies, so we should be pretty good at this. Yeah. But we have room for improvement, and we are taking action.
Which is TDN and Direct.
Lars and I even had an interview with TDN. I would like to talk with Direct as well. Probably we could schedule something for next week. I don't know who should be there. I'm gonna figure out that. And also Inquiry for potentially, because they are using some sort of algorithms to automate a lot of things. So I think maybe there's some synergies there that we are not aware of.
Yeah, I'll try to be brief, Alan, but just perhaps add a sentence here that, of course, we're in a very short time frame. We are working with well-known techniques, right? We're not inventing stuff here, but I alluded to this also. The last slide I was actually the most technical one, but with something called latent semantic analysis and latent Berkeley allocation, which are heavy-duty mathematical processes. What we've had some success with are finding relations between documents that are not necessarily obvious that could help search essentially more relevant documents. That could help. Yeah, that's a doable thing. Just to and.
Good.
You guys probably have your scope for this summer, but
go ahead.
We really should improve our search with this machine learning stuff.
Yeah.
I mean, that's something you actually can do. You can retrieve relevant documents, but the thing is that this is so highly structured data, and this is financial data too, right? So if there's gold somewhere, people have been looking for.
Oh yeah, but I meant also
yeah.
just with the instrument search and stuff we have now could benefit from a little.
Maybe we could have a chat about that.
Could we use this to do? You can do meta-analysis on top of this, so that you can say that okay, we analyze all these documents, so we have these that come on these different feeds. We do meta-analysis on top of that, so that you, in sense, could query. I'm an investor. I'm interested in the Nordic markets. Which are the best news feeds to do research on the Nordic market, for example?
The problem there is that we need to move towards probably to do that right. We need some of collaborative systems, and then we're required to have a deep knowledge on user data, and that's a problem. And we won't say why.
So where do we stand in compared to our competitors after having this launched? Are we ahead of them, or
taking baby steps. Yep. Yep.
So there are more advanced products out there, right?
Pretty much so, yeah. Yeah. But there's so many libraries available, open source, so many good solutions such as Azure, that catching up in this one, I think it's pretty easy and very achievable in a very short run.
So what's the long-term plan?
Conquer the world. First Europe, of course. Any question from the guys online if you didn't fall asleep?
They fall asleep.
No. One question I did have is, like, you know, if you obviously have some sort of ideas or something, I mean, how would you like it to be presented to you? I mean, there's a number of guys in the team. Should we do it like the hackathon presentation video and just submit it and you guys can just check it out? Because
I'm not sure if I understand. So you're talking about how we would present these results, right, as a product.
We put ideas to you.
Oh, how?
Yeah, if I had like ideas or came across clients or something and they sort of had ideas, I mean, in what way would? Because I mean, I wouldn't, you know, it'd be very difficult to call you all into like a Skype meeting. Obviously, sitting here in South Africa, we all have very busy schedules and stuff. I mean, what would be the best way that you guys would like for me to submit proposals?
An email. An email would be sufficient, and then probably a chat just to clarify ideas, because sometimes it's very easy to misunderstand things.
Yeah.
These things. So probably one email and then a chat. That sounds like a great idea. If you have proposals, please go ahead. We really welcome any idea that anyone in the company has, no matter where. South Africa, Oslo, Denmark, Paris. There's no one from Paris. No. You don't care.
Yeah, he is, David.
Oh, David. Sorry, David.
I do care. I'm very sorry. I actually have an issue, a major issue, because Skype is not working, so I didn't catch much of the presentation, sadly. But it looks very promising, interesting. I was actually wondering, do you consider doing some sum-ups of our own news agencies, or the tool could be used for external news, for Dow Jones, for other sources outside of the terminal?
Can be absolutely whatever. Any RSS feed you can think about, it can be taken. Any kind of text can be classified. And much of the classification training, how we train the algorithm, is using Dow Jones, because it has such a rich tagging system, metadata or tags or whatever you want to call it.
The English language models we have now.
Yeah, we're working with English now, but good for us. We have a Nordic language specialist as well, so very likely we will be able to extend to Norwegian and also French, right? You work with French as well.
No, but frankly, we don't need to understand the languages to do our work. But my point was simply that the models we're training based on Dow Jones Newswire will work for English. We can obviously train other ones for
German, French.
Yeah, because when we spoke to Ted and Finangs, and they are hand tagging as well. So we should be able to create a similar model for their things, and if there is but in order to do it for French students, we would have to have that training material.
Sure.
That was just one.
Yeah. So now we are focusing on English. Okay, I think everyone is very hungry here. So.
Right now.